All right, so in case you're stuck on these absolute value equations and inequalities, or if the book examples just aren't good enough for you, I thought I would whip up a couple of extras to help you along. I've got one example of an absolute value equation and one example of an absolute value inequality, and I'm going to whip through these for you. So the first thing, something I see students do a ton, is they try to get rid of these absolute value bars before they isolate them. So this -2 is being multiplied out here, and I can't get rid of the absolute value bars until I get rid of him. I can't use that first green box on page 24 until I get rid of the -2. So I'm going to divide, okay, because that's how you get rid of a multiplicative coefficient, is you just divide it out of there. So when I divide by -2, I get 0.3. I can remember how to divide. Haha, there it is. So, very important fact, must divide first. And so now you've got an absolute value equation, right? I see absolute value equals number. And I'm going to grab that first green box on page 24, and it says, well, listen, you got absolute value of stuff equals number. Well, then the stuff must be the number or the negative of the number. So now I have two cases that I got to solve, right? Q plus 5.1 equals 3.3, or Q plus 5.1 equals -3.3. Either case could be true, okay? So now I solve, right? I mean, these are easier equations. We like it when the equations are easy. So the final answers are Q equaling -1.8 or Q equaling -8.4, okay? This is a perfectly fine format for your answer if that's how you want to give it to me. There's another way that the book writes it. It's called set notation. It's just a different way of writing your answer. All you have to do is say that the solution set is -1.8, -8.4. Just get all those little answers that you found, put them in these little curly braces. This means that they're in a set, and there you go. So both answers are okay. Groovy, we did it. Okay, moving on. Here we have a lovely inequality, and we got to solve it, right? Which means, like I said before, get the absolute value bars all by themselves on that left-hand side. Well, looks like I got to subtract one and then like multiply that dude out of there, right? So here I go. I am subtracting one and feeling like a rock star because I know how to -1. And then I'm going to times both sides by that -3. But, you know, there's a dirty trick here. We're going to talk about why this is true in class. But when you're going to multiply or divide by a negative number, you have to flip the sign. So this is super important. Might trip you up as you're working your exercises. Reverse the symbol. So now that we've got the symbol correct, check out the green box on page 27, the last one. It says if you have absolute value of stuff greater than or equal to a number, well, you have to write pretty much this exactly. You've got stuff less than or equal to the negative number, and this means that this stuff could be like -2, -3, -4, so on. Or it could be 2, 3, 4, 5 or bigger, right? Either one of those works. So you have to have the word or there. And I'm going to emphasize this. This is probably the most important bit in this line. You have to have the word or. After this, these dudes are easy to solve, right? Add 1, divide by 4, feel like a rock star. So the solution on this side, x less than or equal to 0, or the solution on this one, x greater than or equal to 2/4 or 1/2. And this, just like up here, where I had Q is this number or that number, I'm okay with this answer. The book writes them slightly differently. The book writes the answer in what's called interval notation. And so the solution set is millions and bajillions of numbers, right? 0 and everything below that, 1/2 and everything on top of that. So the solution set is -infinity to 0, union, that means add this other stuff too, 1/2 to infinity. See how I put the little square brackets in there? That means that I want 0 and 1/2 to count. So once again, both are okay, and I am done.